Good evening everyone. Our bubble tea shops has been growing really well. Big sales and our marketing has been working very well. So I think we should expand and open new outlets. I agree, Lina. Our social media engagement is climbing each week and our customers keep requesting for us to open new branch. But before expanding, we need to confirm whether our sales is strong enough or we can even support the new branch. Oh, exactly. Yeah, we shouldn't rush. Lava, since you're handling in our financial data, can you break down our sales growth using the math concepts we learned?
Absolutely. Let's start by reviewing our sales trend for the first two outlets. I'll summarize everything so we can make an informed decision. Now let's begin with outlet 1. Our first month sales were RM2000, so that makes it A equals to RM2000. And the sales increased by 500 ringgit per month steadily. So our difference is going to be RM500. And this forms an arithmetic progression where it starts with 2000, increases by 500, so 2500, and the next one 3000, and so on. Okay, now we are going to calculate the sales in the 6th month. So we have to find T6 using this formula. Tn is equals to A plus n minus 1 D. T6 is equals to 2000 plus 6 minus 1 times 500. Your T6 value is RM 4500.
That's a strong progression for our new outlet. 4,500 by 6 months shows consistent and also reliable growth.
Now, let's move on to the total sales after 6 months. To calculate the total sales after 6 months, we use this formula. Sn is equals to n over 2, 2a plus n minus 1 times with d. So to find the total sales after 6 months, we have to find S6. So we substitute 6 in this. 2, our A is 2000 plus 6 minus 1 times 500. And when we calculate this, the total sales after 6 months, we will get 19,500 ringgit.
So outlet 1 earned 19,500 ringgit in 6 months. That's a solid linear growth pattern, exactly what a stable arithmetic progression trend looks like.
Now let's look at outlet 2. This branch started with 3,000 and the sales grows by 10% per month, right? So since the growth is percentage based, this is geometric progression, right?
So now for outlet 2, we started off with 3,000 ringgit sales in the first month. And the sales increased by 10% each month. Since the difference is in percentage form, this forms a geometric progression. So the first month is 3,000 ringgit. When it increased by 10%, and when we increase 10% for 3,000, you get 3,300. And from this, when you add another 10%, you get 3,630 ringgit. So this is our geometric progression. So based on this, we are going to calculate the sales for first 6 months. And we're going to use this formula. So T6 is equals to 3,000, which is our A. And our R is going to be 3,300 over 3,000. So you get 1.1 is our R. So we take this and we substitute here. 1.1. N minus 1 is 6 minus 1. And when we calculate this, our sales after 6 months is 4,831.53 cents.
That's impressive. Outlet 2 grows faster because the percentage growth compounds month after month.
Next, we're going to calculate the total sales after 6 months for this geometric progression. So we'll be using this formula since it's geometric progression. So to find the total sales after 6 months, we are going to find S6. Our A was 3,000. R is 1.1 and our N is 6 minus 1 over R minus 1, which is 1.1 minus 1. So our total sales after 6 months is 23,146 ringgit 83 cents.
Okay, now we're going to use metrics to analyze our staffing costs across both outlets. This gives a clear picture of our operational expenses. So the first column represents the number of cashiers and the second column represents the numbers of baristas. In outlet 1, we have 2 cashiers and 3 baristas. In outlet 2, we have 1 cashier and 4 baristas. So this is the wage for the staff, cashiers being paid 12 ringgit per hour and baristas being paid 15 ringgit per hour.
So multiplying this should give us the labor cost for each hour, am I right?
Exactly. So to find the cost for the staff, we need to multiply the staff numbers by the wage. In order to multiply this, we need to multiply first row with this column and second row with this column. So it's 2 3 times 15, 1 times 12, and 4 times 15. And then we add this with this, 24. So this is the labor cost for each hour. Outlet 1 costs 69 ringgit per hour and outlet 2 costs 72 ringgit per hour.
And what about the weekly operating costs?
Each outlet operates 10 hours per day for 6 days. So the total is 60 hours. So 60 times 69, we get 4,140 ringgit for outlet 1, and 60 times 72, we got 4,320 ringgit for outlet 2.
That's very clear. Can we also check if the matrix is invertible?
Yes, first we find the determinant. Since the determinant is 5, the matrix is invertible.
Oh, great work, Bernie. This gives us a detailed understanding of our staffing budget. I review all the analyses. The AP growth at outlet 1 is stable. The DP growth at outlet 2 is accelerating. And geometric breakdown for staffing is very close. So, with the numbers looking strong, can we move on with the extension? You have my approval. These mathematical projections show that your business is financially healthy. Let's move on to your next audit. This project really shows how mathematics help us make real business, from AP to GP and to matrices.
Numbers don't just describe our growth, they explain it.
Cheers to growth and to bubble tea!